All right, here we have a 10-year loan of 2000 is to be repaid with payments at the end of each year. It can be repaid under the following two options: equal annual payments at an annual effective interest rate of 8.07%, installments of 200 each year plus interest on the unpaid balance at an annual effective interest rate of I. The sum of the payments under option 1 equals the sum of the payments under option 2. Calculate I. Okay, great. So we could easily use a financial calculator and annuity notation, but I'm going to just do it from first principles. So we have 10 payments, right? And we pay, it's worth 2000, and we don't know how much we pay, but we make equal payments. Okay. So we want to find the value of each one at time 0. Okay, so the first one's going to be x over interest rates given to us, 1.0807. Next one's going to be x over 1.0807 squared, so on and so forth. Now I'll show you a good technique on how to deal with geometric series. So just all we got to do is write the first two terms, recognize the pattern, then we factor it out. So x over 1.0807, and then I get 1 plus 1 over 1.08. We'll write that a little better. So it's 10 terms, okay? Now, what's the sum of a finite geometric series? It's a1 minus r to the n, right? Sorry. All over this, right? Probably seen that before in like algebra 2 or something. Now, I think it's easier to think of it as you distribute it, so it's first term minus first omitted term, right? First stands for omitted, just want to write it. And then we divide by 1 minus common ratio, okay? So let's go ahead and take that approach here. I get first term minus, now, the first omitted term is going to be 1 over 1.0807 to the 10th power, because this is to the first power and it's the second term, so the first omitted term has to be this. You could, of course, use a negative exponent if you'd like. 1 minus the common ratio. 1 minus 1 over 1.0807. Okay? Then we still have this. And all of that is going to equal 2,000. Okay? So this is not that hard. I would definitely recommend to use a calculator. I would actually recommend to use negative exponents because I would make it like this. I would say 1 minus, it makes it really easy to put in the calculator, 1.0807 to the negative 10th divided by 1 minus 1.0807 to the negative 1. Okay? So when I simplify that on the calculator, I get 6.69 x equals 2,000. And you get, once you solve for x, you get 299. So each payment's 299. So the sum of the payments is times 10, 2,990. Okay, great. Now for part 2, installments of 200 each for 10 years. So that's going to be 200 times 10. Now, you pay interest on the unpaid balance. So just think about what's going on, right? You're going to pay, we've already dealt with the 200 payments. So you're going to have 2,000 I. And then you already paid the 200, so you're going to have 1,800 I. And this is going to continue all the way on to 10 time period 10 where you have 200i. Okay, so it's an arithmetic series. So we're going to add the first and last two terms. We get 2200i. There's 10 terms, so let's multiply by half of that. So times 5, because there's that many pairs, right? So I get 2200 times 5. I get 1100, okay? So plus 1100i equals, some of the payments are equal to each other, so the first payment is equal to this, okay? So we just have a simple linear equation. You guys know how to solve that. So you solve for I, you should get, so we get 990 divided by 1100, and we get 0.9, so 9%, okay? So remember, geometric series, first term minus first omitted term, all over 1 minus the common ratio. This should be a C, okay? So you can always just go back to first principles. There's an easy way to do this on a financial calculator, BA2+, but like I said, you can always revert back to first principles, okay?